So in the previous episode about fat loss, we talked about lipolysis, the breakdown of fat into fatty acids so it can be used as fuel. And it ended in a step where we got ATP, which is the bottleneck and final common path for all energy producing functions in the body. There are other ways, but basically ATP is the key element there. Now, with muscles, they don't function on fats normally. What they are going to function on, their ability to move and their ability to do things and allow us to move in any way that we want to, is based on a process of glycolysis, the breakdown of things like glycogen and glucose into energy. And it's a very simple process. You don't have to know any chemistry. So if I say the words carbon or hydrogen or something like that, don't freak out. You don't have to understand any chemistry. But basically what happens is you've got this available sugar resource that's stored in muscle, okay? And that's glucose. And that glucose has 6 carbons and 6 waters, basically. That can be broken down into 2 sets of 3 carbons, all right? So basically you take glucose and you break it into these 2 little batches of carbons that we call pyruvate. So 6 divided by 2 is 3, so you get 3 and 3 pyruvates. And that generates a little bit of ATP, of energy, but just a little bit. Now, if there's oxygen available, okay, if there's sufficient oxygen there, what can happen is that pyruvate can be brought to the mitochondria. And through a whole set of things that you probably don't want to hear about right now, like the electron transport chain and citric acid cycle, what happens is it's broken down and you get 28 to 30 ATP, which is a lot of ATP. So the only things you need to know about this process is that glucose and glycogen are broken down into pyruvate. You get a little bit of energy from that. And when I say energy, I mean the ability to move. It's fuel. It literally just gets burned up. But if there's oxygen available, and that's key, then within the mitochondria, you can create 28 to 30 ATP, which is a lot of ATP. Now, what does this mean? This means that movement of muscle is metabolically expensive. And indeed, compared to other tissues, compared to fat, compared to bone, compared to almost all other tissues except brain tissue, muscle is the most metabolically demanding, which is why people who have more muscle relative to adipose tissue, to fat, they can eat more and they're more of a furnace. They just kind of burn that up. So even if you didn't understand anything that I just said, what you probably did hear, and that I hope you heard, is that if you have oxygen around, you can create energy from this fuel source that we call glycogen and glucose. But what if there isn't oxygen around? And what is that like? Well, you've experienced that. I'm not talking about oxygen in the environment. I'm talking about oxygen in the muscle. So if you've ever carried a box while moving, or you were carrying heavy groceries to the car, or you were exercising particularly hard and you felt the burn, well, that burning, which most people think is lactic acid, is actually a process by which pyruvate, which, as I said before, normally could be converted into ATP if there's oxygen. Well, if there's not enough oxygen because that muscle is working too hard or too long, what ends up happening is that a hydrogen molecule comes in there and you get something called lactate. So believe it or not, humans don't make lactic acid. That's in other species. We make lactate. And we think and we hear that lactate is bad. We need to buffer the burn or avoid the burn, that lactic acid and lactate are what prevent us from performing as well as we ought to be able to, or for going as far as we possibly could in an endurance event. Guess what? That's not true at all. Lactate has 3 functions, all of which are really interesting and really important. First of all, it's a buffer against acidity. You don't want muscle to get too acidic because it can't function. You don't want any body tissue to get too acidic. So that burn that you feel is acidity in that environment. That and lactate, what most people call lactic acid, but again, we don't make lactic acid. Lactate is there to buffer that, to reduce the amount of burn. So most people have this exactly backwards. So when you feel that burn, that is not lactic acid. That is lactate that's present to suppress the burn, to suppress acidity. It's also a fuel. When you feel that burn, lactate is shuttled to those areas of the muscle, and there's an actual fuel burning process where in the absence of oxygen, you can continue to generate muscular contractions. Now, this is informative because it also tells us that burning, that acidity that we feel, can inhibit the way that our muscles work, but that lactate comes in and allows our muscles to continue to function. So we'll talk a little bit more about what this whole lactate thing and the burn means, but it's a really important process, and it's amazing to me that most people understand it in exactly the incorrect way. They think, oh, lactic acid is bad and the burn is bad. No, it reveals a number of really important things are going on with this vital molecule lactate, which can reduce acidity, reduce the burn, as well as act as a fuel. Now, here's where it gets really, really cool. And if you don't have enough of an incentive to exercise based on all the information out there about how it'll make you live longer and make your heart better, etc., here's a reason that regardless of what kind of exercise you do, if it's weight training or running or cycling or swimming, that every once in a while, about 10% of the time, you should exercise to the point of intensity where you start to feel that so-called burn, right? The reason for that is that lactate shows up to the site of the burn, so to speak, and it acts as a hormonal signal for other organs of the body in a very positive way, okay? As you may recall from a very early episode of the Huberman Lab podcast, I talked about what a hormone is and how it works. We have lots of different kinds of hormones, but hormones are chemicals that are released in one location in the body and have effects on lots of other organs of the body. So when I say that lactate acts as a hormonal signal, what I mean is that it's in a position to influence tissues that are outside of the muscle. And basically, it can send signals to the heart, to the liver, and to the brain, and it can have effects on the heart, the liver, and the brain that are very positive. Okay, so just to zoom out for a second, I promise we won't get any more technical than this. We will get into tools and protocols that are really straightforward. But what I'm telling you is that if you feel a burn from a particular exercise or movement, that burn is going to be buffered by this molecule we call lactate. Lactate will then provide additional fuel for additional work. So this is a good incentive, provided you can do it safely, to quote unquote work through the burn. That burn is acts as a beacon to the lactate, which comes in and allows you to do more work. It's not a signal to stop necessarily. I mean, stop if you're doing something unsafe, but it's a signal that lactate should come in and allow you to continue to do work. And it can act as a hormonal signal. Lactate can then travel to the heart and to the liver and to the brain and can enhance their function in positive ways, not just in those moments, but in the period of time that follows. So many people are curious about how they can exercise to make their brain better. That's one of the most common questions I get. What I'm telling you is that provided you can do it safely, by engaging the so-called burn, which is a different threshold for everybody, right? Your hill run will be different than my hill run to generate the burn. But provided you can do that for about 10% of your workout or of an individual workout or activity of any kind, you are generating the activity of this lactate-based hormonal signal that can improve the function of neurons. And it does that, if you want to know, for the aficionados, by improving the function of another cell type called the astrocytes, which are a glial cell type, which are very involved in clearance of debris from the brain. They're involved in the formation of synapses, connections between neurons in the brain. So put simply, if you're an exerciser, if you're doing movement of any kind, and you're interested in allocating some of that movement toward enhancing brain, heart, and liver health, there is a nice set of scientific data that points to the fact that getting lactate shuttled to the muscles by engaging this burning sensation is advantageous for the health of those other tissues.